Hello everyone, myself Varsha and my teammate Siri are going to explain the topic arrays. Let's start with the introduction to arrays. An array is a collection of items stored at continuous memory location. The idea is to store multiple items of the same type together. This makes it easier to calculate the position of each element by simply adding an offset to a basic value, that is, the memory location of the first element of the array. The above image can be looked as a top-level view of a staircase, where you are at the base of the staircase. Each element can be uniquely identified by their index in the array, in a similar way as you could identify your friends by the step on which they were on in the above example. Basic operations in arrays. The basic operations in the arrays are insertion, deletion, searching, display, and update. These options are usually performed to either modify the data in the array or to report the status of the array. Following are the basic operations supported by an array. Traverse prints all the array elements one by one. Insertion adds an element at the given index. Deletion deletes an element at the given index. Search searches an element using the given index or by the value. Update updates an element at the given index. Display displays the contents of the array. Types of arrays. One-dimensional array. The simplest type of arrays. One-dimensional arrays contains a single row of elements. These are usually indexed from 0 to n-1, where n is the size of the array. Utilizing its assigned index number, each element in an array can be accessed. Two-dimensional array. Two-dimensional array type are arrays that contain arrays of elements. These are also referred to as matrix arrays since they can be thought as a grid that lays out the elements into rows and columns. Each element within the two-dimensional array can be accessed individually by its row and column location. This array type is useful for sorting data such as tables or pictures. Multi-dimensional arrays. Multi-dimensional arrays are a powerful data structure used to store and manage data. They can have any number of dimensions, the most common being 2 dimensions, rows and columns, but 3 or more dimensions may also be used.
Hello everyone, today I'll be explaining about the examples of arrays and advantages and disadvantages. So first we have the example of one-dimensional array. So here we allocate the memory only for a single variable, that is 10, and then we print the 10 integers values and we apply a for loop. If the for loop does not work, we get an error. So here it is working as we put I is equal to 0, I less than equal to 9 and I plus plus. So here we check for each numbers and then in the last we have put get ch, that means to receive the character as input. Thirdly, in two-dimensional arrays we apply two variables, that is rows and columns, and here we have given two sizes, that is 2 2. So here we have taken 10 and 20, 30 and 70. So again we apply it for the for loop. So if rows is equal to 0 and rows is less than 0 and then rows plus plus, that means if rows is equal to 0 it gets printed, and then rows less than 2, so it's true. So row plus plus, that means it adds the number, so then it goes to the columns, it checks for rows and columns, and then later it returns 0. Then for multi-dimensional arrays we take more than 2, that is example we take 3 in this program. We have given 3 variables with 3 sizes. We take the for loop and then check for each variables. First we check for tables and then rows and then columns. First we check if it is equal to 0 and table is less than 2 and then tables plus plus, that means it adds the number. We check it for all the 3 variables and then we pass a print statement, and then in the later we give return 0 as we have put int main in the first. Next about the advantages of arrays. So first we have memory efficiency, performance, cache locality, simple implementation, and flexibility. So first the memory efficiency, it allocates memory location for each element for their element. So this sequence result in efficient memory usage as there is no additional pointers or overhead needed to link elements together. Next is the performance. Due to the memory efficiency, arrays generally offer the better performance compared to the other data structures for operations like searching, accessing, and modifying elements. Next is the cache locality. Since array elements are stored in adjacent memory locations, accessing elements in sequence can make better use of CPU cache, leading to improved performance. So simple implementation, as arrays are straightforward implementation, it makes them easy to understand and use in programming. The last one is the flexibility. So arrays can store elements of the same data types, but modern programming language often support arrays of different types or multi-dimensional arrays, providing flexibility for various data storage needs. Next, we have the disadvantages of arrays. So first is the fixed size, static memory allocation, insertion and deletion overhead, inflexible size, and last, poor performance for searching and sorting. So first we have the fixed size. In many programming languages, arrays have fixed size determined at time of declaration. This means you need to know the maximum number of elements the array can hold upfront, which can be restrictive if the size needs to change dynamically. So next we have the static memory allocation. Arrays technically allocate a fixed amount of memory, even if actual number of elements needed is smaller. This can lead to memory wastage, especially if the array size is significantly larger than required. Next, insertion and deletion overhead. Inserting and deleting the elements in the middle of an array can be inefficient, especially if array needs to be resized or elements need to be shifted to accommodate the change. Next is the inflexible size. As we know that arrays have fixed sizes, if you need to store more elements than the array can accommodate, you must allocate a new array with larger size, copying the existing elements over. This resizing operation can be costly in terms of time and memory. Last is the poor performance for searching and sorting. So while arrays offer efficient random access, searching and sorting operations may not perform as well compared to the other data structures like hash tables or trees, especially for large data sets. Thank you.